Today we're going to go over how to graph rational functions. All a rational function is a function where it's a polynomial divided by a polynomial. So like you have x's, x squareds, all that stuff on top, and you have it on the bottom as well. So when you're looking to graph these, there's 6 main steps you have to follow, and I've written out right here. First, you have to rewrite the equation in factored form, so you got to factor. Then you have to find the x-intercepts and the y-intercepts. This here says find the x-intercepts by finding the zeros of p of x. All p of x is whatever the numerator is. So in this example here, the numerator would be 3x squared minus 14x plus 8. So you use this to figure out the x-intercepts. To get the y-intercepts, it's a little bit easier. All you got to do is plug 0 in for x. Usually what happens is most of the terms go away, and you just look at the last number on the top and the bottom, and that gets you your y-intercept. Next, you have to find your vertical asymptotes. Getting these is pretty much the same as the x-intercepts. You just look at the bottom. So q of x there, that just means the denominator. And you take whatever the zeros of the denominator are, and those are your vertical asymptotes. To find the horizontal asymptotes, this is similar to finding the limit as x approaches infinity. But pretty much if the degree on the top, p is the top, remember. So if the degree on top is bigger than the bottom, so if it was like x to the 5th over x squared, we actually wouldn't have a horizontal asymptote. And if the other way, if the degree on top is smaller, so if it was like 1 over x or x over x squared, then our horizontal asymptote's just the x-axis. It's at y equals 0. But probably the trickiest is when the degrees are equal to each other. So like in this case here, we have 3x squared on top and x squared on bottom. The degrees are equal. What you do is you take the leading coefficient from the top and divide it by the leading coefficient on the bottom. So in this case, it's 3x squared on top, and well, x squared, that's just 1x squared. So the leading coefficients are 3 and 1. So this asymptote would be at 3 over 1. You kind of get rid of everything and just focus in on those leading numbers. And lastly, you have to identify any holes in the function. And that just means you have to find a common factor on the top and bottom. So let's say the top, hypothetically, making up numbers here, factored to x plus 1 times x plus 2. And the bottom factored to x plus 2. Well, because you have an x plus 2 on the top and bottom, the root of x plus 2, or negative 2, is going to give you a hole. So when x is negative 2, there's a hole in the function. We'll go over what this looks like. So those 6 steps, I put them right here on the top of the screen. So let's go through a problem so we can see what this actually looks like with numbers. So if this first one wants us to graph x plus 1 over x minus 5. So the first step's already done. We have to factor the top and bottom. X plus 1's factored, x minus 5's factored, so we're good with that. Next, we find the x-intercepts. To do this, we take our numerator, x plus 1, and we just set it equal to 0. So in this case, our x-intercept would just be negative 1, comma 0. On the graph, negative 1, comma 0, we could just put a point down. Now to find the y-intercepts, we just have to plug in 0 for x. So f of 0, well, the top is going to be 0 plus 1, so that's just 1. And the denominator is 0 minus 5, that's just minus 5. Meaning our y-intercept is going to be 0, comma, negative 1 over 5. So once again, we could put this point down in the graph somewhere right around here. It doesn't need to be perfect. So hopefully these steps don't look too new right now. The fourth one's where it might start being a little bit kind of new and stuff we haven't seen before. To get the vertical asymptote, though, we just take our denominator. So our denominator is x minus 5. And we set it equal to 0. And this would get us our vertical asymptote. So when x minus 5 is equal to 0, we add the 5 to both sides. We get x equals 5. This is going to be where our vertical asymptote is, at x equals 5. Which means on our graph, if we go to the right 5, where x is 5, we could draw a dotted line up and down this graph. And all an asymptote means is when we get close to that dotted line, it's going to start curving either towards negative infinity or positive infinity. Before we get to that, we also need to figure out what our horizontal asymptote is. So in this case, we have an x on top and an x on bottom, which means the degrees are the same. Which means the degrees are the same on the top and bottom, so we have to look at the leading coefficients. In this case, that's just going to be 1 over 1. So our horizontal asymptote is going to be at y equals 1 over 1, which is just 1. So now we can draw in a horizontal asymptote at y equals 1. And lastly, we need to find any holes. In this case, x plus 1's on the top, x minus 5's on the bottom. So nothing's going to cancel out here, meaning there is no holes. For the domain and range here, if we want to fill this in, it's just going to be kind of the same thing as our asymptotes. Our domain is going to be x is equal to everything besides 5. And our range is the same thing, y equals everything besides 1. All right, so we have all this information, but how do we actually get a graph out of this? Essentially, when we're drawing our graphs for rational functions, we always want to try to hug the asymptotes near the end. So when you get to the vertical one, you either want to go up or down. How do you know which one to do? Well, we're going to be taking kind of an educated guess for now. In this case here, these 2 points, our x and y intercepts, are both kind of in this lower left box. So we're going to look to continue the graph in that same lower left box. So when we get to our asymptote, we're going to be kind of going down, so it's going to be going towards negative infinity. And same thing when we stretch it out to the left, we're going to get up to our horizontal asymptote and just kind of hug it to the left. Now, usually when you get to a vertical asymptote, if you're going down on one side, you're going to be going up on the other side. It's going to swap. So we could draw on the rest of the curve up here in the top right. We're going to go through cases where this isn't the case. Essentially, it's because this x minus 5 down here is to the first power. If it was to the even power, it would stay the same. But we're going to get to that later. But for now, just know, normally when you get to a vertical asymptote, most of the time, if you're going down on the left, you're going to be going up on the right. There's definitely a lot of little steps to this. There's a lot of things to remember, but I don't think any step is particularly tough. Drawing the graph can be kind of tough, but most of it's just a bunch of small steps. So the more you do, the more you're going to remember each of these steps, and the easier it's going to get. So this is an equation that comes unfactored. If you notice on the top, we have x squared minus 2x minus 15. So the first thing we have to do for this one is factor the top. So to do that, we have to think what multiplies to negative 15 and adds to negative 2. Well, that's going to be negative 5 and 3. So we could factor the top to x minus 5 times x plus 3. Now, some of you guys might be already going on to step 2 and looking for your x-intercepts, but first, if you notice we have an x plus 3 on the top and bottom, let's cancel them out to just turn this equation into x minus 5. Now, when you cancel something out like that, this is what's going to lead to a hole. In this case, we're going to have a hole when x is equal to negative 3. Because when you plug in a negative 3, you get 0 over 0. So in this case, we're going to have a hole at negative 3. And to figure out the y value of this hole, we use this new equation, x minus 5. So when we plug negative 3 into x minus 5, negative 3 minus 5 gets us negative 8. Meaning at negative 3, 8 down here, way on the bottom of the graph, we're going to have a hole. Now we have this new equation, y equals x minus 5. So now we have this new equation here, x minus 5, and you could use this to get your x-intercept, your y-intercept. Because we don't have a fraction anymore, there's actually not going to be a vertical asymptote or a horizontal asymptote, so we just put none or n/a for them, or d and e, whatever you want. Hopefully you remember y equals x minus 5, that's just the equation of a line, y equals mx plus b. It has a y-intercept of negative 5 and a slope of 1. So we could just graph that line, and it just goes right through that hole. If it's an open circle, it passes through it, but at negative 3, the function's undefined. Everywhere else, though, this function is just x minus 5. It's just a line. So the domain, well, x can't be negative 3, and the range, y can't be equal to negative 8. The y-intercept we just got from y equals mx plus b, so that's going to be 0, negative 5. To get the x-intercept, we actually have to set x minus 5 equal to 0, just the equation of the line equals 0. But this is all stuff you should be familiar with. This is just get the x-intercept of a line. So sometimes when it cancels out like this, it's going to turn into a nice and easy problem. All right, so if you want to pause the video and try to get as much as you can done with this problem, feel free. I'm going to skip over most of it, but I'm going to kind of jump back in when we actually start to graph it. So now would be a good time to pause the video and see how far you can get. All right, so if you did this one, when you factor the bottom, you should get x minus 2 times x minus 3. So those x minus 3 there's cancel out, and you have 1 over x minus 2. With this new equation, there is nothing on the top, so we're actually not going to have any x-intercepts here. The y-intercept, when you plug in 0, you get -1/2. Your vertical asymptote is where the bottom equals 0, so your vertical asymptote is just x equals 2, which I drew in right here. And then your horizontal asymptote, well, it's a bigger degree in the bottom, so that means y equals 0 is our horizontal asymptote. And also, lastly, because we canceled out the x minus 3's, we have our hole at x equals 3. And to get 3, 1, you just plug 3 into your new canceled out equation. So now to actually draw in the graph, if you see we have this dot here in the bottom left, so we're going to guess that it's going to stay in the bottom left. And our hole here is in the top right. The hole's not part of the graph, but we could still use it because we know the rest of the graph should be going, well, right past that hole. And this is what the graph would look like. All right, we're going to do the same thing here, so see how far you can get with this problem. Graphing this problem is a little bit different, so if you want to mark your points and your asymptotes, feel free to do that. I wouldn't draw on the curve just yet, though. But now would be a good time to pause the video and see how you do with it. All right, so we factor the bottom, we get x squared times x minus 1, and these x minus 1's cancel out here, which means we have a hole when x is equal to 1. And we use this new equation 1 over x squared to get everything else. So 1's in the numerator, so we can't get any x-intercepts. If you plug in 0, you get 1 over 0, and that's going to give you an error. So we actually don't have a y-intercept here. To get the vertical asymptote, we look at the denominator. In this case, the denominator is 0 when x is 0. So we have an asymptote right on the y-axis, right at x equals 0. And next, because the degree on the bottom is bigger than the top, we're going to have a horizontal asymptote at x equals 0. And lastly, I already said we have a hole at x equals 1. To actually figure out what the y value of that hole is, you plug 1 into 1 over x squared. So 1 over 1 squared gets us 1, so our hole is right here at 1, 1. So now we know that we have this hole here in the top right, so we could draw on the curve here in the top right. But if you notice, we have an x squared in the bottom here. Because it's an x squared, the multiplicity of this asymptote is even, meaning when we cross over the asymptote, we're actually going to stay going in the same direction. Even means you stay in the same direction. So we could draw on the other curve in the top left. That part's a little bit weird, and I think it might throw some of you off. So a second way you can do it is if you're not sure where the graph should go, just pick any x value, like -1. If you were to plug -1 into the equation 1 over x squared, well, 1 over -1 squared is just +1. So that gets you a new point, which you can now use to say, okay, it's got to be in the top left. Hopefully that makes sense. Desmos is definitely a good tool if you want to check your answers as you can go. All right, so this box here on the right, it's going to stay the same pretty much no matter what I throw at you. The part of this probably going to be the trickiest is just factoring it in the beginning. But if you get past that, you should be able to get through the box. And then graphing it might be a little bit tricky too, but the more you do, the more used to it you get. That's all for today though.